I'm going to go down and push that start button. You can see our first car is starting up. This is a very simple system. It uses time delay to position these streetcars in the appropriate spot to park. You can see that first one went around and parked. Now the second one's going around, and when it crosses that detector on the left, the Mini-Panel, which is controlling this, will start executing a time delay, and it'll time for a certain number of seconds and give a speed 0 command. Now there goes the third car, and again, when it crosses in front of the detector, the relay connected to the detector goes to ground, and the Mini-Panel, which is controlling it, starts executing a time delay. In each successive car, we execute a shorter and shorter time delay so we don't bump into the car in front of it. And they run on speed step 18 while they're on the main line, and when they cross a detector, the Mini-Panel sends a command to slow them down to speed step 12. And that's cruising it, that's going in at speed steps 12. Now we've completed one cycle. There's a time delay of about 4 seconds, and then it'll start repeating, and you can see there comes the first car around past the detector, and the same thing is happening all over again at the second detector. And this is a small loop. You can see they just barely get going, and then they cross in front of the detector and they get slowed down and parked. But hopefully, if you can use your imagination, if we put these on a bigger loop so there's more track in between the detectors, we'll get a longer running time in between when they stop. And what we've got here is we've got 5 Bachmann N-gauge DCC Peter Witt streetcars running on Kato Unitrack. And like I said, this is a simple system requiring no blocks in the track, just 2 detectors and the NCE Mini-Panel to control it. And we can do this for any number of cars, really. We're running 5 right now, but we can run 4, we can run 3, we can run 2, or we can run 1 car. And what we've got, you can see maybe down at the far end leaning up against the wall, we've got an NCE brand DCC power cab, which is the command station providing the power to the system. The power cab provides a maximum of about 1.8 amps at about 13.8 volts. And then we're using an NCE Mini-Panel to automatically control these streetcars. The Mini-Panel is basically a simple programmable model train controller. It's much simpler, in my opinion, than using a computer. You just type some simple commands into it. And as I mentioned, we're basically running 1 streetcar at a time, and we're running at speed 18 on the main line. And then when we cross a detector, we slow it down to speed step 12 after the detector and execute a time delay, and then we send it a speed step 0 command. That means speed step 0 means stop, basically, go speed 0. And I've set the momentum on these cars. They came defaulted to a momentum of 0, and I've set the momentum to 1, which gives them a little bit of a more gradual startup, as you can hopefully see. Our previous videos, 828, video 827, 826, and some of the others, used a single detector to control multiple trains, and that makes it easier wiring-wise, because you've always only got a single detector, but you have to devise a system to move the trains forward from the detector when the next one is coming in, so they get out of the way of the incoming train. With 2 detectors like this, we've always got a completely empty yard area downstream of the detector. I'm calling this area where the yellow one just came in out in front of us here, the yard area. You've always got a totally empty yard area with 2 detectors, so it's just a matter of running all your streetcars, how many ever you have, from one yard area to the next yard area. And as far as our time delays, each one's about roughly 1.5 seconds shorter for each car. Now there's our final car coming in. Okay, now we got a 4-second time delay, and the minute that first car will start up, there it goes. Now that's going to execute a 10.5 second time delay. That is to say 10.5 seconds from the time it crosses a detector till when it stops. And in the next one, the yellow one that's just starting up, when that crosses a detector, there'll be an 8.5 second time delay. In other words, a mini-panel is measuring 8.5 seconds a time, and when that time elapses, it tells that yellow car to stop. Now the third car, that gets a 7-second time delay. Now there's our fourth car starting up, and now we'll get a 5.5 second time delay. Okay, there's our fifth and last car starting up, and now we'll get when it crosses in front of the detector, there'll be a 3.5 second time delay from now when the detector got activated till when that car stops. And I don't know if it shows up in the camera or not, but the reverse lights come on when they stop, and we can do that by sending a speed reverse 0 command to these streetcars. With NCE systems, you can send a speed forward 0 command or a speed 0 reverse command, and it stops the loco either way. But when you do a speed 0 reverse command, it turns the lights on, that whatever lights are activated in reverse. And with these streetcars, it turns their rear light on. So when I see those cars sitting over there with the rear lights on, I know they're getting power. And if you can see it, when like that yellow one starts up, you'll see the light will go out. It just did now, and when that light went out, that means it got the speed forward command. And if you watch the red one, the light just went out. The tail light just went out on that, which means it got the speed forward command. And as far as these detectors, we've got a Z-Stuff DZ1012 on the right, and that's a low enough detector. It'll detect an N-gauge trolley without anything on the top of it. And the one on the left is a DZ1011 detector, and that's a taller detector, and it doesn't pick up it doesn't detect an N-gauge trolley. The trolley's too low, and it sneaks underneath of it. I had to add about an inch of height with these paper note cards you see on top of the trolleys to get the detector on the left to activate. And they're both driving they're both connected to a DZ 1008 relay, also made by Z-Stuff. And when the detector goes to red, when the car crosses in front of it, that closes the relay, which grounds an input on the mini-panel, which is how the mini-panel knows that the streetcar crossed in front of the detector. And this is basically running on Kato Unitracks. There's 2 detectors. They're wired in parallel. You could also use a magnet and a reed switch or an electric eye, although I'm thinking getting a magnet on something as small as an N-gauge streetcar might be a little bit tricky. Now they're starting up their last routine, or next to last car. Wait till that car comes in and stops, and what I'll go do is go down there. Okay, I'm going to go down there and open what I call the repeat switch. Now I just opened what I call the repeat switch, which is connected to input 18, and all that'll do is when the cycle of these 5 cars completes, if that switch is open, it'll stop executing this routine, which means the cars will just stay there parked. Okay, there's our 4th car. And our 5th car is just started up. And that's stopped. Now normally we'd have a 4-second time delay, and then the first car would start up again, as you've seen as these things have been running. But because I opened the repeat switch, that tells the system, or all it does is it stops executing commands, so our cars will stay parked. Now if we close the repeat switch and push the button, everything will start up again. There's the repeat switch. I'm going to push the start button. There's about a 4-second delay. Okay, there we go. Now you can see the car started up again, and they'll continue running as long as we keep that repeat switch closed. Now I just went down there and opened that repeat switch, so again, when they complete this cycle of running, they'll park on the other side, and they'll sit there and wait until we give them a start command again. Okay, there's the 3rd car, or 4th car, I mean. And there goes the 5th and last car. And again, as before, they're stopped, and they'll sit there and wait with their lights on stopped until somebody closes that repeat switch and pushes the start button again. Here's another look at our system. You can see we've got a small loop of Kato N-gauge unitrack with no blocks or anything in it, just the 2 detectors. And you can see these detectors, these Z-stuff detectors, they don't even connect to the track, which is a nice thing. I can just pick the thing up and move it. That's the DZ1011, and over here is the DZ1012. And again, these are just sitting next to the track, but they detect the trolleys by infrared beam. When I put my hand down, like when the trolley goes past, it interrupts the beam, and you can see it goes to red and goes back to green when it clears. And there's that's the DZ1008 relay, and all that's doing, that's controlled by this detector. When this goes to red, it closes the normally open points on this relay, so they're closed, and that grounds input, I think it's input 18, 16 on the mini panel, which is this wire here. And that's how the mini panel knows that the train, or in this case streetcar, has gone past the detector. And over here you've got the familiar NCE power cab, which a lot of people are familiar with. And what we've got here, this thing is the right here, this little square panel. That's what they call the NCE Mini-Panel. The label's upside down, but that's the Programmable Model Train Controller. And then here's my start button, which is nothing more than an old American Flyer push button. And this is what I call the repeat switch. This is just a toggle switch wired to input 18 on the mini panel, where we can tell it to repeat or stop running the routine. And then some of this other stuff is left over from previous videos. It's not being used right now, but that's the basics of this system. So it's a fairly simple system. I like it because you don't have to wire any blocks in the track. You can see the only connection to the track. We've got one connection to the track, which is here. We just have a standard Auto track connector. That's really the only connection to the track. We just have one connection, and the two detectors here and over here, which are sitting alongside the track. But we can, like I say, using that simple system, we can control 5 streetcars on the same track. Now we'll take a quick look at the commands used to run this system. And every so often the question comes up on the N-Scale Facebook groups, what kind of an NCE system or what kind of a DCC system do I want to buy to run my N-Scale trains? And one reason to consider this NCE power cab back here is it's probably one of the best robust systems on the market. And besides that, it's made right here in the United States in the Rochester, New York vicinity. And if being the best system isn't reason enough, the second thing is you can do stuff with it like this, run multiple trains on the same track fairly easy by using that mini panel back there, which I'm going to talk about, or did talk about. And you have to, NCE is the only system that makes a mini panel like that. If you want to control your trains automatically with the other systems, you got to go to what I consider a much more complex computer-controlled system like Train Controller or iTrain, or if you're smart enough, you can figure out JMRI, how to use that. But for simple-minded people like me, this mini panel is a good way to do simple train control. We've plugged a Pro Cab into the programming port of the mini panel, and that will allow us to take a peek at the commands that are controlling this streetcar system. And you can see our 3 options are set up. That's where we actually put the commands in. And 3, the bottom one, is we can test operation. We can actually test it with this thing. And we just want to review commands. That means look at them. So I'm going to push a 2 down here. And it says review input. And I'm going to tell it to go to input 16, which is where this starts. So I just said review input 16. I'm going to push the enter key down below. And there you can see it says input 16, step 1. And that's a test question to see if the repeat switch is closed. If it's closed, it switches over the next command, which is a terminate end statement. And then there's a delay statement. That's a quarter second times 16. That gives us our 4-second delay when we start repeating a routine. Now here's the actual commands to control the cars. And these are really pretty basic. Regardless of whether you're running Lionel Legacy or MTH DCS system or the standard DCC system, that's what we're running here, the standard NMRA DCC system. You got to tell the system what loco you want to control, and that's what this statement does. It says select loco 1341. That's the first trolley, the first red car. And this statement turns on function 0, which is the headlight. So once we run them the first cycle, all their headlights have been turned on. And this says speed forward 18. That starts the streetcar up at its mainline cruising speed. And then we say wait till input 14 is ground. That's the detector. When the streetcar crosses in front of one of those two Z-stuff detectors, the Z-stuff relay will change from open to closed, which essentially grounds input 14 and signals the mini-panel that the streetcar has passed the detector. So once that happens, we start executing the delay state. No, first thing we do is decrease the speed from 18 to 12. You noticed when they went past the detector, they slowed down, and that's what this statement does. It slows it down to speed 12. Now we start the time delay, a quarter second times 42. That's a 10.5 second time delay for the first car. And when that time delay is finished, we say speed reverse 0, which stops the car. And as I mentioned before, there's a speed forward 0 and a speed reverse 0. And by using the speed reverse 0, that turns on the car's rear light. Now we're ready to start running the next car. We've completed running one car. We're just going to do the same thing all over again. So here's the second car. Select the loco, turn on the light, start it up at speed 18, wait till it passes in front of the detector, reduce the speed to speed 12, execute a delay of a quarter second times 34, which is 8.5 seconds. So same thing, except that we're executing a shorter time delay because we want the second car not to run into the first car. We want it to stop behind the first car. And basically what we're doing here is using time to estimate distance. We can't tell these streetcars to go for 2.5 feet past the detector, but we can use a time delay to approximate that 2.5 feet or whatever distance we need. And then there's our stop command, speed reverse 0. And then there's the next car, 1342. And then this just continues for however many cars you've got on the system. And when you get to down to the bottom of this thing, you just have a link to the top statement, which it takes back to the top and starts running up all over again. So it's pretty simple, really command-wise. There's a video 816 on the AutoControls.org website, which tries to show how to get started with this mini panel. That seems to be the sticking point, getting people to use it. And the documentation of all these commands is at AutoControls.wordpress.com, which is part of the AutoControls.org website. Just look for video number 830, which is this video. It'll be the copy of these commands, the wiring diagram, and whatever other pertinent documentation.